first. So I like to make it stand out too. It stands out, big dy dx in there. Okay? We haven't seen this yet. What rule do you think I have to use? I have to use one of these old power rules, or quotient rules, or product rules, one of those rules, because it's got a letter x times a letter y. Which rule is it? Where it's a product. It's called the product rule. We have to apply the product rule there. I'm sorry, no option. We have to. You've got an x times a y. I have to do, let's put it in our notes, little, hey, you need prod rule here. Write it down, guys. I'm going to need product rule. I'm not going to forget it. Well, it's pretty easy. Who's the m? Who's the m?
X is m.
All right, x is m. And y is the what?
N.
N? Yeah? All right. First times the derivative of the second plus the second times the derivative of the first. Okay, let's hope I don't mess up this product rule. You fixed my problem last time. All right, what's m? And what's m? X. What's n? What's n? Just a what? Y. Now, do I have to do anything goofy with that n? No, because it says just write down the what? The letter n. According to product rule, right? What else is easy? What's m prime? 1. I love it. So these three parts were easy. M was the x from product rule, right? N was the y. That was easy. And what's the derivative of x with respect to x? Just a what? 1. But here we go again. This is telling me by product rule I have to differentiate what letter?
Y.
And every time we do that, right? We differentiate it, then we write down what? dy dx. But what is the derivative? Y, you told me, just what? But what do I have to write right next to it? Because, yeah, that's exactly it. So I think I'll write 1 dy dx to give it emphasis. So for this part right here on that m prime, I'm going to say 1 dy dx. See, every time I differentiate the letter y, what am I writing? Dy dx. Now students have asked me for years why I didn't put a dy dx over here. That's the misconception. You know what they do? They go, I thought every time you write the letter y, you have to put dy dx. No, 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 no. You're close, but that isn't it. It's every time you're differentiating something with the y. Does that make sense? We're doing product rule. Product rule said first times derivative second plus the second times derivative first, right? When it's plus the second, we just write it. But when you differentiate it, you got to put the little what? Dy dx. Or some students like to just put y prime, and you can. Those of you in here who prefer that. Those of you in here who are very organized, and you're very neat in your writing, and you're comfortable just writing y primes here and y primes there. Now when the hard part is over, but do you remember my last step to implicit differentiation? I said you had to isolate the dy dx. Well, hold up. How many dy dx's are there? How in the world are we mathematically going to get one of these? I heard it. Someone said you're going to factor it. So let's stay clear with our algebra here. That's a 4x cubed. That's an x dy dx. There's a plus right here. Let me get it in here. Everyone see that plus? I think I'll write this again. Just write it neater. 4x cubed plus x times a dy dx plus a y times a 1 plus a 2y times a dy dx. See, I like to make it stand out. Equals what number? 11 or 0?
0.
I know, a lot of students write 11 sometimes. I forget about that. What you want to do, when I say I need you to isolate that dy dx, you go, what's the process, what's the algebra technique? Anything that does not have a dy dx, would you get it on the other side of the equation right away? Right now, what doesn't have a dy dx? Get it over on that other side. So how do I get this over there? I just what? For some, you just put it over here and change the sign. What else doesn't have it? The y, what would I do? So go subtract it on both sides. Look. Da-da-da, da-da-da. So now look what you got. Oh, we are closing in. Oh, you are closing in on the answer for dy dx to this funky curve I made up. Oh, yeah, but I still got 2. Ugh. I still got 2 dy dx's. Ugh. How many do I want?
1.
But Amber, do you see my technique? This is called algebraic manipulation. I said anything that did not have a dy dx multiplied to it, other side of the equation, right? Now I've got everything with dy dx's here. And here comes that word, starts with an F, so you can get one of them. Starts with an F, yeah, it's not a bad word. What? Let's have a look. Factor. Factor out of dy dx. Yep, factor it out. That's what you do. Once you get everything with you factor it out, just one of them. Now what's left over? X. And you bet you the answers in this section look weird. Yep. You're going to get some funny looking answers in this section. What's dy dx? Last step. All you got to do is divide it. All you have to do is divide it. Your final answer. Here it is. Hard part is over. Negative 4x cubed minus y all over. And sometimes students think they can do more with that, but I don't think you can you? Can you do anything more with that? Cool. Good job, everyone. Evan, if you actually want to find and compute a slope, we can for fun. Let's just make up a really small y value. How about the y value of y equals 2? Will that work? Mm-hmm. All right, y equals 2. Now let's use an x value of 1. Is everyone okay with that?
Okay.
So the only thing is if I did this, you'd be like, come on, Professor Messenger. If you're just picking just a typical point like 1, 2, that point has to be right on this curve. Do you agree? Mm-hmm. So can I tweak this a little bit? If x is 1 and y was 2, 1 plus 1 times 2 is, what's 1 plus 2? 3 plus, what's 2 squared? 3 plus 4? 7. Do you all agree? So let's just make this a 7, for example. Did you know this next step, what would this be?
0.
Right? But is that point on that curve? Just to give us something we can play around with? Is that point on that curve? 1 plus 1 times 3 plus, yep. So what would be the slope at that point? This is slope. This finds slope. This has great application. It finds instantaneous rate of change. It finds the slope of that curve. That weird curve I made up. All you gotta do is it finds the slope at that point. You just plug in a point. If you did it at that point, Alan, I'm just gonna say here, look. Oh, well, let's substitute at the point 1, 2. So you're gonna plug in 1 in for x and 1 in for y. Plug in 1 for x and 2 for y. You get negative 4 minus 2 over 1 plus 2 times 2. So negative 6 over what?
5.
Just to give an example. That would be the slope of that curve at that point. Slope of a tangent line to the curve. Oh, let me go back to you. What if they said slope a normal line? Oh, just take it, what? Flip it and change the what? Okay, they don't do it often. They don't do it often. Cool.
Are you going to do it on the exam?
No, I think I'm just going to go slope and tangent line. You okay with that? Mm-hmm. I know, because it would just, you might be like, no, do it. It's an extra problem. All we got to do is change the slope. I think I'll just do slope and tangent line. I know. Hey, let's see how crazy this gets. I want to throw a few of these in. Let's see if you're just an expert with this stuff. Go into directions. Find what? dy dx. All right. What kind of differentiation is this called where the y is kind of mixed in the middle? Not explicit, but implicit differentiation. Here, try this. All right, y cubed x. Everyone, you notice a product rule there? Mm-hmm. All right. y squared, oh, y'all notice a product rule there?
Mm-hmm. Mm-hmm.
Equals 2. So I think this thing's gonna get long. How many product rules you gotta apply?
4.
You need a prod rule here. And you need a prod rule here. Because I'm going to differentiate that side with respect to x. I'm going to differentiate this side with respect to what? X. So here I go. M times n prime plus n times n prime. Want me to use u and v because I already used m and n? First times derivative of the second plus the second times derivative of the first. This is u. This is v. This was m. This was n. Product rule, right? Oh, my favorite part. What will this be equal to? What's derivative of 2? 0. Yeah. Don't put 2 there. Be careful. What's m? Is that agree? What's n prime? What's n? Here go the bells. Bells are ringing right now. Find m prime. M is what? Y cubed. We're going to write 3y squared and right next to it, dy dx. Kelly, outstanding. Everyone agree? I'm going to write 3y squared dy dx. Why? Because I'm differentiating with respect to x. What? Chain rule. So right here, dy squared dy dx. Every time I differentiate that y, I'm putting dy dx. I want to tell you what's common on my tests. So all that's done, but we got to do a product rule on this one.
No, I meant again.
Oh no, great question because it's a 3.
Oh, sure.
I know, great question. Hey, Kelly, this is what's common on my test. There's something about this, Owen. That's perfect, that's perfect, that's perfect, that's perfect, and students write 3y dy dx. There's something about the y cubed. They just think the derivative is what? It's not, it's 3 what? Power rule becomes 3y squared, right? If it was y to the 10th, it'd be 10y to the 9th. Good. All right, now there's a plus between these, and what's the u now? What's the u?
Y squared.
Y squared. What's v prime?
2x.
2x plus, what's the v?
V
X squared.
squared.
And here we go. What's u prime?
2y dy dx.
2y dy dx. I'm not writing y primes up there, and I think they get all confusing. Look at all the writing. You might miss it with your eyes, but you can if you prefer that. There's a lot of students in this class, you're like, I took calc before. I like to write y prime. The author does it. Stuart does it. He finds it easier just to put a y prime there and a y prime there. He finds that easier to write. Right.
Can we write y prime in the final answer, I guess?
Heck yeah. And if you want to, trust me, I'm not going to mark you wrong and go, why did you write y prime here? The author does it. Me as an instructor on a board, I get so worried that this next to something like that or something, someone might think that's y to the second, y to the first. Because my derivative slashes, maybe I don't slash them enough or something, right? So for emphasis, I always write what?
dy dx.
Do you remember the next step? How do I get dy dx by itself?
Take factor common.
Check anything on this side that doesn't have a dy dx. So what would go over here? That what? Y cubed, right? Oh, so I just put it over here? Hold up, we subtracted on both sides, so what sign would it be? So watch, I mean, this is where a lot of students like to save time writing. Because this is a lot of writing. So in your head, you're like, okay, I would subtract y cubed on both sides, get that. Now how would you get this thing over here? Okay, I'd have to get this, it doesn't have a dy dx, I want it on that side of the equation, I'd have to subtract it, right?
Mhm.
So I'll subtract it, it would become a negative 2xy squared.
Mhm.
Is that okay with that? So here, let's get these off here, then look, we're going. We subtract everything, there it is. Well, let me write everything that's left over here, what do you have now? Oh, and I like to clean this up a little bit, look what you have, you got a 3xy squared dy dx plus a 2x squared y dy dx. Equal to that. What did we do next? Sometimes students stop, they go, I got confused, I didn't know what to do
You
next.
can factor out.
Factor, and then what do you do with that part that's left inside, which is what?
Divide on the other side.
So when you may find yourself doing 2, 3, 4 steps at once with these. To save writing, it's up to you. But when I grade it, I'm not one of these, like, where's the 5 steps? If you were taking an AP exam, like my old days with my AP, yeah, I'd be telling them, write every step, because they're going to get that person's right, you know. You never know if that grader's going to be like, nah, they didn't show everything. You're going to love these answers. What's the slope then? There it comes. Negative y cubed minus 2xy squared all over. Don't miss my minus here. Whoa. I got all of you to back me up. Now, this is my answer. I want you to stare at it and let me know if you think you can do anything more.
You can factor out at y squared.
Brilliant. Good eye. Me personally, I give full credit for that. If you're like, do I have to simplify that? I give full credit. Because I'm going to do a part B and say find the slope at a point anyway. Not a crazy point, something like 1, 2 or something.